Okay, let us now start our experiment number 4. Okay, this is all about the Zener diode and the DC power supply. The objectives of this experiment or activity is to analyze Zener diodes, Zener diode applications, and regulator circuits. The intended learning outcomes are analyze the forward and reverse bias characteristics of a Zener diode, examine the regulating characteristic of Zener diode, and examine the operation of basic DC power supply using IC regulator. Here, we have the characteristics of the graph of the Zener diode. So this is the voltage versus the current. Okay. And this is the forward part of the graph, this one, and this is the reverse one. And this is the schematic for the DC power supply. So we have the input, the rectifier, the filter, the regulator, and the output. So first, we have the activity 1 entitled the Zener diode. Okay, so we have these equipments listed here. But as for we are now online, so we will use the the multi-sim or the live multi-sim. Okay, but for this activity, I will use the multi-sim. Procedure. So this practical illustrates the forward bias characteristics. Okay, um, and the same as those conventional diode and shows that when reverse bias, they break down at a defined voltage and suffer no damage. Okay. So the general guidelines. Okay, so click on the simulator. Okay, so at this case, we have opened the multi-sim. Next, make sure the connections. Okay, so first, we make the connections. Okay, so for it, we can copy this diagram and paste it here. Why? I can't select it, so I think I guess I need to select it from here. So we will paste it here, and then we will make our connections. So first we need the power supply. So in this case, we will use a DC voltage power source. Okay. So this here, the voltage, the positive variable power supply, and the negative variable supply. So this will act as the this DC power source. Okay. Next is we need to put a two multimeters. Okay, so two multimeters. Next is a 1 kilo ohm with zero tolerance resistor. Okay, so we will select resistor 1k point 0, 1.0k. Okay, and put it here. Then we need the Zener diode. Click basic, then we have these diodes. So where is the diodes? Then here we have the Zener diodes. In this case, we will use this one indicated here, BZB84. BZB84. P84. P7V5. B7V5. Okay, so this one. So we will use it. Select A. Cancel. Okay, close. Next is we need the 2K potentiometer. Okay, So we need to place a potentiometer. It's basic. And then we have our potentiometer. So select 2K potentiometer. Okay, and then put it here. Close. And we will now make our connection, but we need a ground for it, for our system to work. So okay, click ground and select OK. Now we will make the connection. Okay, so we need this one. Rotate it. And need the 1 kilo ohm resistor. So we will put it here. Connect this one to the Zener diode. This one to the 2K potentiometer. Okay, this one. And then we need to put it this one, connect this one. And then we need to put this one to this one. Okay. Now let us okay. So next is we can connect this ground here, so that you know this ground. Okay. Now we need to have a DMM or digital multimeter. So that will be volts. So we need to put it here. Okay, we can put it here. We can also change it the position later. So we need to adjust the font. Apply. Okay. So here it is, our connection. So we'll now test it. Okay. So this reading, the 12 volts reading. So in order for us to know if this potentiometer is working, we can drag this here and made our reading. So at 80% we have the 7.46. So we press A to add voltage, to add the percentage. Okay. Then shift A to okay. So that's it. So our connection is working, and this is the pre circuit that I have made. Okay, so this is the final circuit. This is what it looks like. Okay, now we need to adjust the PVPS or set our DC voltage to 3 volts. Okay, so we will now set this one to 3 volts. Okay, and then next is we need to set the increment to 0.1 volts. Okay, so we need to change this one. So we need this 0.1 or 10%. Okay, so we need just say 0.1. And then we need to know the voltage from 1.5 up to 3 volts by adjusting the potentiometer. And then after that, we will replace it by the negative power supply, or we will just reverse bias our Zener diode because we don't have this negative DC power supply here. Okay, so we can only do it using the NILVs. So first we need to measure the voltage at 0 volts power supply. So in order to do that, okay, let us simulate our circuit. Okay, so I have set this one to 0, and then our voltage reading here is almost none. Okay, so that is 300 nanovolts or 600 MV peak to peak. Okay, so that means there is almost no current flowing here or voltage flowing here. So this is the our values 0.605 FB. Then we will record it. Okay. This one. So as we can see here, so these are the values that I have gathered. Okay, so this is the reading for XMM1. Okay, so I have here 0.909 FV of M2 volts. Okay, and then at 3 volts. Okay, so let us now skip. Okay, we have this 6.01 NV. Okay, so let us now see. Okay, so it should be 2.262 volts. Okay, so we have reverse bias our connection here. So the readings was for this one. Okay. Okay, so I've just realized that our connection is in reverse bias, so we need to change this one. Okay, so I'll just rotate it. Okay. Okay, so that one. So we have this 2.262 volts. Okay, so this is this one. So we have this 2.262 volts. So here are our reading. Okay, and then at 0 volts we have this 0.909 FV of femtovolt. Okay, so we will adjust this to, yeah. Okay, so we have this. Okay, so and so on and so forth. We have adjusted our the potentiometer to this supply voltage value and arrive to these values. Okay, so you can see, and also we have reversed the bias circuit, the Zener diode, I mean. Okay, so we have reversed the Zener diode as the connection kanina. Okay, and then set the voltage to up to 10 volts. Okay, so this is the maximum voltage we have here, so up to 10 volts. So we need just to rotate this one and make it reverse bias. Okay, so we need to set this to 0 and then start simulating. We have our reading here, at 300 nanovolts for XMM2 or the VS. And then we have this 0.609 femtovolts for the voltage across the resistor. Okay. So, but in some case, or along the experiment, we have encountered errors when we are adjusting the potentiometer. So at approximately 70%. Okay, so I have not yet changed the voltage. So as we can see, we have this message, there is an error in our simulation, okay? But when I am adjusting this to 0 volts, okay, so there is no problem. So there is a certain amount of percentage of the potentiometer wherein this circuit is failing. Okay, so we need to set this one to 10% and let us see. So we need to press A to increase this by 10%, by 10%. So I have now 30%, so the circuit is not yet failing, okay? At 40%, so it's not yet failing. Okay, 50%. Add another 70%, okay? Working. And 80%, 90%, and 100%. Okay, so it is now working. So, but when I have conducted kanina, so it is not working. Maybe there was an error. 2.567. So in some instance, this circuit is failing. So let us try if we will put it to 7 volts. Okay, so we need just to decrease. So 1.152.936. So we have the same record here. So let us now try for the 8 volts. So I don't know why is it failing kanina. Okay, but now it is working. So, yeah. So we have just reverse bias our circuit. And we have obtained these values. Okay. So we will just fill this out later. Okay, this one. So, and then we will graph it. So in some point, this circuit is failing. So as we can see, this is stated here that there is a breakdown at a defined voltage and suffered no damage. So, yun. So maybe that fault is because of that. Okay. So this is the final circuit. Okay. So we have here the DC power source, the potentiometer, the multimeter, and then the Zener diode, the 1 kilo ohm resistor. Okay. So that is all for activity 1. And here are our gathered data. Okay, so we will graph it later. Next, we will go to activity 2 entitled the Zener diode voltage regulator.